Oh, check your work. Here's the solutions. Just stop it here if you need to look over your work. I'm going to move on. Okay. Um, the greatest standard deviation will be the distribution that has the fattest tails. It's got to be B. Okay, that has more data in the tails than any other distributions. Notice they all have the same spread. They all have 10 dots. But only B has the most data in the left and right hand tail. Therefore, it's going to have the widest spread. The IQR is from 20 to 15. Okay, so the IQR is about 15. So here's Q1, here's the median, and then here's Q3. This is the minimum, this is the maximum, this is the end of the fourth quartile. Okay, this is skewed to the left, skewed in the direction of the tail. Tail goes to the left, it's skewed to the left. Okay, for 4, the only possible answer is the bank does not need to use an inference procedure because it's a census. They surveyed all 60 employees. Okay, you have 175 patients. The median is going to be where the middle is. So in the first column, 0 to 5, you've got 80. The next column, you've got about 50. That's 130. So in between, somewhere in that second column has got to be the median. It's not in the first one, but halfway through, you're going to be, so maybe 7.5 is a good guess for 5, and that's the right answer. Okay, now you got Q1, Q2, Q3, and the median is Q2, 44.27. Half the customers are going to be less than 44.27, and half are going to be greater than. That's the definition of what the median is. And so the answer to 6 is A. Now what's going on here, they tell you a male grizzly has a z-score for, what's the z-score of a male grizzly? It weighs 530 pounds. Well, a male, the mean is 500 and the standard deviation is 50. So Z is going to equal y minus mu over sigma. So that's going to equal 500 and that's 530 minus 500 over 50. So Z equals 0.6. So you're going to find a female that's 0.6 standard deviations. And so you're going to take 300 plus 0.6 times 40. And that would be what? 324B, 7B, yeah, okay. So 8. All right. Now you've got a mean of a 19.25 standard deviation of 5.76. Now you describe the profit. You take the variable and you multiply it by 75 and you take away 100. So measures of center are affected by multiplication and or division, addition, and subtraction. Measures of spread. Measures of center include median and median and mean. Measures of spread are standard deviation, range, and IQR. And those are affected only by multiplication or division. So you simply take take the standard deviation 5.76 and multiply it by 75, and you're going to get 432, and that's B. All right, now the way you're going to do this, you got 0.027 equals X times, now they tell you, well, we use the formula, okay, margin of error equals Z star times the square root of PQ over N. Okay, so we got to find Z star. Now we know PQ, P is 0.6 and Q is 0.4, and we know N, it's 900. So X is going to equal 0.027 divided by the square root of 0.6 times 0.4 over 900. So we'll get the calculator. Get it over here. Okay, and you can see it's 1.65, which is the Z star for 90%. So it's 90% confidence interval. Okay, so the found a significant difference, and all right, it's reasonable to conclude that the difference in sales was caused by different cover designs because they were randomly assigned to the stores. There's no way to have a control group. A control group is not necessary in order to have an experiment, or even to have an experiment to establish cause and effect. Sometimes a control group is not possible. You couldn't have a CD without a CD cover or whatever. It has to be covered with something. So they decided which one was better, and this is reasonable. And they randomly assigned the covers to the treatments, so the procedure is okay. So the answer is D. 10 is D. Okay. Dirty towel turned in, placed in a washing machine on premises. Washing machine contains 20 towels. Flips the detergent A. All right. Flips a coin. That's random. Cleanliness of the load is rated on a scale of 1 to 10 by the person who does not know which detergent was used. It's blind. The manager continues the experiment for many days. It's completely randomized design. Okay, there's no blocking. Okay, and there's not a washing machine, or there's no. Okay. If there was blocking, things would be divided into subgroups and whatnot. Okay, it's just completely randomized design. Now, design of a survey. You're asking questions. Okay. Increasing sample size does not reduce bias. Decreasing sample size certainly does not reduce bias. If the questions are bad, randomly selecting the sample will not reduce bias. If the questions are bad, increasing the number of questions will not reduce bias. Questions have to be developed carefully and tested to see if they're not going to have, if they're going to be free of bias. So E is the right answer. Okay, now 13 is a question about the distribution of the data within the sample as opposed to the sampling distribution. So we look at A. It says distribution of weights is approximately normal because of the sample size. The sampling distribution is approximately normal because of the sample size. But the distribution of weights in the sample isn't made normal because of the sample size. Okay. A sample has a distribution within itself. Okay, it has a mean, standard deviation, and so on. It has a shape, center, and spread. But that's not the same as the sampling distribution of the statistic taken from that sample. If the sample size is random independent, not too big, not too small, approximately normal, or big enough, then the statistic taken from that sample will distribute normally with statistics taken from similar samples, and they will distribute normally around the true mean of the population from which they are drawn. That's the sampling distribution. This question is about the distribution of the sample itself. Okay, and it's going to be skewed to the right because the possible weight is within because the least possible weight is within 2 standard deviations of the mean. So the answer is C. 14, for some reason, wasn't included, so I'm going to skip it. Okay, this is a little unclear. When I first read this, I thought it was intimating that it was simply randomly concatenating phone numbers using a random number generator and then calling those numbers. But it's instead, it was just I must be calling phone numbers from a directory or something, because the answer that it's given is that registered voters with unlisted telephone numbers will be underrepresented in the sample. All right. You got A, B, and C, and they got probabilities of failure for each one. If any one component fails, the device will fail. They are independent of each other. So, what's the probability the device will not fail? Well, the probability that it will fail is the sum of the probabilities of the 3 independent components failing. So 0.01 plus 0.03 plus 0.04, that's probability of failure. So the probability it won't fail is 1 minus that sum, which is 0.922. So the answer for 16 is D. All right, this is pretty simple. You just take the number that's in between the in the center of the confidence interval, and that is what I had worked this out before. You take the difference, 0.112 minus 0.048. What is it? 6432 at 48 plus 32 is 80. So 0.080, I believe, is the center. 17C, that's the right answer. Okay, so in other words, it is, remember, the confidence interval equals P hat plus or minus P hat Q hat over N. Okay, so what they wanted was the point estimator, that's P hat. All right. Move on. All right, what's going on here? We want, why do we want the population to be at least 10 times bigger than the sample size? Well, this is to maintain the independence of the sample, and this goes back to the very beginning of when we start talking about sample sizes. So if the sample gets too big, then the effect of drawing the sample out of the population itself changes the statistic of the population. So when you get a sample, 10% is considered to be the point at which a sample size changes the population statistic, and thereby ends independence among the sample. So the 10% rule is to maintain independence, whether you're talking about proportions or you're talking about quantitative data. All right, so I had to stop for a minute and reread this one. Um, the expected value of the net gain of each ticket is 95 cents. What's the meaning of the expected value of this content? Well, in this context, since they're only giving away, they're collecting $1,000. They're only giving away 50, so it's pretty clear that on each ticket you're only getting back 5%. So each ticket's going to lose on average 5%. So each ticket owner will lose an average of 95 cents per raffle ticket. Okay, so the answer is B. All right, 20. The alternative hypothesis mu is less than 10. Suppose that the alternative hypothesis is true. So that means the null hypothesis, h sub 0, mu equals 10. All right, for a fixed sample size, the power of the test will be greatest if the actual mean, that is true mu, not mu sub 0, but truth. Well, remember, h sub a is mu is less than 10. So the power is greatest if the further that mu is from mu sub 0. So in the negative direction. So here's mu sub 0 equals 10. Okay, mu equaling 8 is the furthest away from that, and that gives the most power. All right, so the answer is A. So the further that mu, truth, is from the null hypothesis and in the direction of the alternative hypothesis, the greater the power of the test, the greater the probability is that the test will reject the null hypothesis. All right. Which plot provides strongest evidence of regression? Is consistent? Well, that can only be C. All right. The first one, all of them are bad. You got homoscedasticity here and here. Okay. Here's the only one that looks random is C. All right, probably didn't need to go over that one. Now, which of the following statements best summarize the meaning of this confidence interval? About 95% of all random samples of 50 students from this population result in a 95% confidence interval. That's wrong, okay? Chances are you'd never get those two numbers again. About 95% of all random samples of 50 students from this population result in a 95% confidence interval that covered the population. Now, that's the meaning of the level of confidence. 95% of all of the students in the survey reported sleeping between. Okay, that's wrong. That's not what a confidence interval means. 95% of the students, no. Actually, the right answer for this, which of the following statements best summarizes the meaning of this confidence interval? Well, I mean, B is a true statement, but that's really the meaning of 95% confidence. I mean, the interpretation of the interval should be, we are 95% confident that the true proportion of, that the true average number of hours of sleep per day is for students, is between 6.73 and 7.67. But B is the best answer, so we got to go with that. All right. You're going to look at this, you're going to think, oh, I'm going to have to do a test, or I'm going to do this or that or other thing. It's pretty straightforward. Just look at one question at a time. Find one that's true. Person owns a car. If the person owns a car. Okay, so car ownership, go across the S. There's 60 people that own a car. He or she is more likely to live elsewhere in the city than to live in the downtown area. Okay, what's the probability if you own a car that you live in the downtown area? 10 out of 60. Elsewhere in the city, 15 out of 60. That is true. Okay, the answer to 23 is A. As soon as you find a true statement, just go on. Okay, now you go through this other stuff and you can be there the rest of your life. Okay, so A is true. And let's move on. All right, 24. Random sample 432 revealed that 100 are in favor of a bond issue. Okay, 95% confidence interval. All right, so you have to look at, okay, 0.5 and 0.5. Well, that's not 100 out of 432. Okay, so we know that that's out. So A and B are out. Okay, remember, it's the confidence interval equals p hat plus or minus z star times the square root of p hat q hat over n. Well, p hat is 100 out of 432. Okay, it ain't 0.5. All right, so A and B are out. Now, all the rest of them have 0.23 and 0.7, so you know that p hat is going to be 0.23. All right. So that, all right, so C has 0.23, but it's got this 100. Like, what's that all about? Okay. All right. So it's got to have p hat. So D has p hat and E has p hat. But E has the confidence level for 90%, 1.645. So the only possible answer can be D. It's got p hat, 95% confidence is 1.96, and then square root of p hat q hat over n. Okay? So 24 is D. All right, now look. The mean is 30 minutes. What's the probability it takes 35 minutes or more? Okay, so he takes extra 5 minutes. Okay, standard deviation is 5 minutes. Okay, so that's one standard deviation away from the mean. So what's that going to? That's 16%. Okay, remember, it's 34, 34, 13.5, 13.5, 2.5. So you can see right away that one standard deviation to the right is going to have 13.5% plus 2.5 is going to be 16%. So the answer is 16. Okay, that you should know. Be able to do that in your head. Okay, to find the size m, let's see, it wants 98% confidence. Okay, so it's not 1.96, so it's going to be 2.33, and they found that at 79%. So you're not going to use 0.5 and 0.5. You don't have to do that. Okay, so and the confidence interval is 0.025, so it's got to be 2.33 times 0.079, 0.021. Things you're going to solve. So 26, it's got to be D. Okay, provide the assumptions which of the following tests should be conducted to determine if brand name batteries. Okay. All right. Last longer. That's a one-sided two-sample t-test. 27 is B. Experimenter conducted a two-tailed hypothesis. Okay, here's the deal with this thing. Probably I'll figure this out. Okay. All right. It's two-tailed, and the p-value is 44. So it means you got 0.22 in each tail. Great. Okay. Now we're going to do one-tailed test. So you can think, okay, the answer is 0.22. However, that's only if you did, let's say, less than. Okay, but suppose you did greater than. So the other test you could have, besides a 0.22, is a 0.78. So 28. The answer is D. 0.22 and 0.78 add up to 100. Those are the two things if you went with either greater than or less than. All right. Which the following statement is going to be true? Well, you got to do the freaking experiment, so you got to get the calculator out. Okay, no, I don't want this. Let's close that. I don't want that. Okay. So we're going to go here, and I'm going to clear this. I better do this. Tools and restore default state. Yes. Okay, so we're going to do stat and tests, and we're going to do a 2-sample t-test, number 4. Now, we don't have the data, but we have the statistics. So I'm going to hit enter for the statistics, and then we're just going to put them in. So we're going to put in the first average. That's X bar 1, 19.54. I hit enter. First standard deviation, 3.68. Hit enter. And then the number, 16. Okay, and then the second average, 23.39. Hit enter. Second standard deviation, 4.93. And then N is 17. Okay, so now, performed, give different yields. Not one greater than the other, so we're doing not equals to. Okay, arrow down. Pooled, no, we're not going to pool. Now we do the calculate. All right, now the p-value is 0.016, so let's see what answers match this. Okay, now first of all, that's significant. Okay, so we look at A. There is no statistical evidence because p is greater. Well, p is definitely not greater than 0.15. P is not between 0.15 and 0.10, so B is out. There is evidence of a statistically significant. Well, P is not between 0.10 and 0.05. Okay, but P is between 0.05 and 0.01 because it's 0.016. So the right answer is D. 29 is D. $30. Okay, what are you doing here? Well, you want to see if there's any connection between car color and vehicle type. So, what do we have? We got 2 variables, color and type. All right? It's not like we have one variable and a whole bunch of categories. Okay? That would be color, and then we got these categories, red, black, white, tan, and green. And we have vehicle type, which has 2 categories, car and truck. But we got 2 variables. All right? When you have 2 variables, the only thing you really can do is a chi-square test of independence. Okay? If it was goodness of fit, you'd have one variable and a bunch of categories and then some expectations. If it was a test of independence, of homogeneity, you'd have a variable and a bunch of categories, and then you would see if they had changed over time. But here you got 2 absolutely totally different variables. When you have that, you got a chi-square test of independence. All right, 31. Okay, the drug. Let's see, the drug effects difference. Versus people taking a placebo. If the drug had no effect whatsoever. Okay, all right. The drug has no effect. Okay, that means the p-value is going to be greater than 5%. How often? Well, the p-value is 5%, right? Okay, so randomly, it's going to be less than 5%, about 5% of the time, and it will be greater than 5%, 95% of the time. Okay? That's the whole idea if your level of significance is 5% and you don't reach it. Okay? 2, there'll be equal number of experiments showing positive and negatives of the drug effect. That's absolutely correct. Okay? Because some will be above 0 and some will be below. That's if there's no effect. Okay? That means that the difference between them is 0. That's the null hypothesis. Okay, 3. When 95% confidence intervals are constructed, these confidence intervals will contain 0 about 95% of the time. That's correct, okay? Because again, the confidence intervals, 95% of the time, will maintain the truth of the null hypothesis, that the difference between them is 0. So all 3 are true. The answer to 31 is E. All right, random sample, let's see, students, important number of hours spent studying for the final exam and their score. Okay, She wants to construct a 95% confidence interval. Squares regression line. Which of the following gives the margin of error for the confidence interval? Okay, now the standard error for this. Okay, it's going to be 2. Okay, it's 2.228 times. Now, the standard error is 0.745. Now, the standard error of the study hours is underneath the standard error, and that already takes into account the square root of 12. Okay, so there's no reason to bring that. That's it. All right. So 32. The answer is A. All right. Okay, this one, I've been through this a million times. Definitely skip this if you've already seen this. All right. Here's what I did. Okay. You want to think of this from the point of view of either getting it right or wrong. If you get it right, you get 7 points. If you get it wrong, you get 0. Okay? Now, if you are guessing you're guessing. Okay, so you're guessing from 5 questions. So, x equals, and then the expected value of x. All right. So, if you're guessing from 5 questions, the probability of getting it right is 0.2 and getting it wrong is 0.8. So your expected value is going to be 0.2 times 7, which is 1.4, and that is less than 2. And you get 2 points if you don't answer anything. So on average, if you're guessing out of 5 questions, you definitely want to just say nothing. Now suppose you eliminate one of the answers as being wrong. Okay, so now your probability of success is 0.25, your probability of failure is 0.75. So now, what's your probability of success? It's going to be 7 over 4, which is 1 3/4, still less than 2. Okay, so if you've eliminated one answer, on average, you still want to just answer nothing and get your 2 points. If you eliminate a second question, that brings you down to guessing from 3 questions. So your probability of success is 1/3 and failure is 2/3. Okay, so now your expected outcome is 7 over 3, which is 2 1/3, and that's greater than 2. So if you have eliminated 2 questions, on average, you're best off if you guess. All right. So the answer is C, 2. 3. The probability that a new microwave oven will stop working. Okay, all right. Oops. Here. Okay, now here's how I did this thing. Okay, now you've got all these. This you have on your sheet here. Okay. So the probability that it stops working is 0.05. The probability that it stops working and is damaged is 0.04. The probability that it gets damaged, and this is kind of ridiculous. But anyway, the probability that it gets damaged is 0.1. Now, what they want to know, given that it's damaged, what's the probability that it stops working, right? Okay, is going to equal the probability that it stops working and it's damaged divided by the probability that it's damaged. Okay, I mean, they're really just setting you up here, okay? If you just put up the numbers, and it's going to be, which is going to be 0.04 divided by 0.1, which is 0.4. Okay, so the answer is 40, which is 34 is D. All right. All right. People who live in a farm. Okay. Now, a random sample of 28 produces a mean. Okay, following is appropriate alternative hypothesis. Okay, the person doing the research, the null hypothesis will be mu equals 24.5. Okay? And, right? Because you would start out saying it's okay. And then the alternative hypothesis, mu sub 0. Okay, h sub 0. Colon mu. All right. The alternative hypothesis, if you're worried, and you're doing it, which is why nobody's going to be worried that it's less than this, will be that mu is greater than 24.5, that it's too high. So the alternative hypothesis is mu is greater than 24.5. 35 is D. 36. Okay. Computer, which following is a correct interpretation of 19 in the output? Okay, so let's just, just for grins and giggles, okay. Estimated zinc hat equals 16.3 plus 19 times lead, okay, and that's zinc in parts per million and lead in parts per million. Okay, so on average, the predicted concentration of zinc, on average, there's a predicted increase of 19 parts per million concentration of lead. Okay, no. Okay, this is having lead. A has lead being the consequential variable and zinc being the explanatory variable, when it's really the other way around. B, on average, there's a predicted increase of 19 parts per million in zinc. Okay, good. For every increase of 1 parts per million in concentration, that is it. Okay, so 36 is B. Okay, that is the correct description of the slope of the line of best fit. 37, distribution of sales price strongly right skewed. Okay, all right. So you got sample size 100 are drawn from this popular computer. Now the following, sample size is big. Okay, so the sampling distribution will be approximately normal. Okay, because I got a nice big, and it just says it's random samples of 100 drawn from this population. Okay, so it's random, independent, and it's certainly not too big, and it's going to be nearly normal because the sample size is nice and big. All right, so we're going to have approximately normal distribution, and the mean will be the population mean 206,274, and the standard deviation is going to be 37881 divided by the square root of n, which is 100, which is 10, so it's just going to be 3788. So the answer for 37 is A. Another one of those problems that you can do in your head. Okay, she gathers information, arrows are excellent, blah, blah, blah. Which following might be an appropriate null hypothesis? Is different? No, not null. Is the same. The average number of hours exercised for each call is the same as. Okay, B looks promising. Okay, A is out. Greater, C is out. D less than is out. The probability is 0.5. That's crazy. E is out. The answer is B. 38 is B. Okay, now 39. Okay, you're taking differences, which means you're going to go from -5, okay, because you can have 1 minus 6, to 6 minus 1 to 5. Okay, now how many different ways can you get a -5? 1 minus 6. That's the only way you can do it. How many ways can you get a 5? 6 minus 1. So there's only one. Now, if you look at how many are there ways to get a 0, you can do 6 minus 6, 5 minus 5, 4 minus 4, 3 minus 3, 2 minus 2, 1 minus 1. All right, so there's 6 ways to get a 0. One way to get it. So right away, your distribution is going to be mound-shaped. Okay, so you look at, okay, this one doesn't, A doesn't have any negatives, B doesn't have any negatives, E doesn't have any negatives, D is uniform, so that's out. So the only possible answer is C, and C is the right answer for 39. Okay. Okay, 40. Now here's the deal with 40. And we're done. All right. So the probability of winning game is 0.5. So let's put that on this. So here's good old 0.5 right in the middle. Okay. Now, if at least 70% of the games in end games are won, you get the prize. Okay, so you want to get to 0.7. Okay? All right. So So z equals 0.7 minus 0.5 divided by the standard deviation, okay? Or the standard error, whatever. Okay, now, the smaller that the z-score is, the higher this probability is, right? So if this was just one z-score, it would be 16. If it was two z-scores, it would be 2.5, okay? So we want the z-score to be as small as possible, which means we want the standard deviation to be as big as possible. The bigger standard deviation, the smaller the z-score. Okay, if the standard deviation was 0.2, then the z-score would be 1 and it would be 16. If the standard deviation was 0.1, and then the z-score would be 2, and then it would, the probability of success would just be 2.5%. So, which denominator gives the biggest z-score? Okay, well, the standard deviation is going to equal the square root of 0.5 times 0.5 over n. Okay, the smaller the denominator, the bigger the standard deviation. The smallest denominator is 10, so 10 gives the biggest standard deviation, and that'll leave the smallest z-score, which gives the highest probability of getting to 0.7. Okay, so n equals 10 is the right answer.